Good day, students. I want to go through with you this past exam question which came in May-June 2023. As you can see on my whiteboard, it's 0620 paper 31, May-June 2023. I want to look at question number, this was question 7, and it's part D. If you check in one of my videos, I did this displayed formula for mesoconic acid, but today I'm going to talk about how to calculate the relative molecular mass of a compound which we form, which is called an ester, when ethanoic acid reacts with ethanol. All right, this is one of the way in which examiners can ask you to determine the relative molecular mass of this compound C4H8O2. Right, so let's go through it. It says ethanoic acid reacts with ethanol. The organic product has a molecular formula C4H8O2. Complete table 7.1 to calculate the relative molecular mass of C4H8O2. Right, so we're going to analyze the compound that we're given, and then we're going to use the information on the number of atoms to complete the table. Right, so if you analyze, carbon has already been done for us. We have 4 carbon atoms, and we're going to say 4 multiplied by 12, and we get 48. Now let's move on to hydrogen. So if we do hydrogen, I'm just going to annotate for you so that you can see how we complete the table. Okay, right, so if you check for hydrogen, we have 8 atoms. So how are we going to complete? So 8 atoms, yes. So down here, we're going to write our 8, okay, right, like that. And then if here, you're going to say 8, okay, just like what has been done above. I'm going to say 8 multiplied by 1, okay. If you say 8 multiplied by 1, you're going to get 8, okay. So we are done with the molecules for hydrogen. We'll move on to oxygen. For oxygen, we have 2 atoms. So what we do here, we indicate 2 to indicate the number of atoms present. And then we're going to say 2 multiplied by 16. So yes, 2. Okay, we're just following the method used above, 2 multiplied by 16, and then we're going to get here 2 multiplied by 16, we get 32, okay? Right, and then once we get 32, what do we do? We're going to say 48 plus 8 plus 32. If you do that, you're going to get your answer. It will come up as 88. So that's how you're going to get the molecular formula of this compound, which is C4H8O2. Okay, so that's how you complete the table, and that's how you are going to fill it so that you have the relative molecular mass of C4H8O2. Okay, then the next question is ethanol can be manufactured by fermentation. Complete the word equation for one other method of manufacturing ethanol. Okay, I hope you still remember that if we ferment the glucose, you can actually manufacture the alcohol called ethanol, but we can also use this method of hydration. Okay, what we just need here will be a gas, an alkene, okay, which we call ethene. All right, so I'll just do it like that here so that you can see the answers. Okay, right, so inside here, I'm just going to write ethene. Okay, ethene, that's hydration of an alkene. And then what we also need, also shorten it so that you can see what's happening here. Okay, right. So ethene, what we do is we carry out what we call hydration of ethene. And then if we hydrate our ethene with water, and to make the reaction fast, we use steam. So our complete equation is going to read ethene plus steam. We're going to get ethanol. Okay, so this is hydration of alkenes. If you hydrate alkenes, you change the alkenes to alcohols. Okay, so there are 2 acceptable answers here. You can either say ethene plus water or ethene plus steam. Yes, hope you remember that water can exist in 3 physical states at room temperature. It can be water, liquid water that we drink. If you put the water in a freezer, it becomes ice, but if you boil it, it becomes steam. So in this case, we want to make the reaction faster. So we say ethene plus steam, and then we get ethanol. So that's the answer to D and part E. Okay, so before I move on to the next page, I'm going to wrap this. I hope you still remember the answers. So I'm clearing my drawings, and then I move on to the next page. And let's see the next page. This question is about nitrogen and compounds of nitrogen. I hope you still remember the element nitrogen and the fact that it is a poor electrical conductor. Describe two other physical properties of non-metals. There's a range of answers that you can put here. Okay. You can also write that, don't keep the answers very complicated whenever you're given an option. So you can simply say here, non-metals are poor thermal conductors. Non-metals are poor thermal conductors. They conduct heat poorly. Okay. You could even say non-metals, as opposed to metals, non-metals have low boiling point. Okay. Non-metals have low boiling point. Okay. You can also say non-metals have low melting point. Okay. Right. So all these are properties of non-metals. There are other properties that you can also look at here. We know that metals are ductile, metals are malleable. So non-metals are the opposite. They are not malleable, they are not ductile. So all these are properties that we can list here. Okay. Oxides of nitrogen are air pollutants which contribute to acid rain. State one source of oxides of nitrogen in the air. Okay. The chief culprit here could also be car engines. Okay. During combustion of petrol, we also put a lot of oxides of nitrogen in the air. And then B part 2 was reading, state one are the adverse effects of oxides of nitrogen. Oxides of nitrogen have a lot of problems. Health-wise, they can actually cause respiratory problems. Okay, so here we could put an answer like the fact that they can cause respiratory problems. So our answer here we could say respiratory problems. That is in as far as our health is concerned. Respiratory problems. Can type in that answer. Okay, in as far as the environment is concerned, okay, they are responsible for what we call photochemical smog. Photochemical smog. They are responsible for causing that photochemical smog. That's what the oxides of nitrogen would do. In as far as environmental concerns uh, are done here. So never put multiple choice for examiners. Here I'm putting alternatives so that you can pick the one which you're going to remember. But when you're answering your questions in the exam, you don't put multiple choice. Don't give the examiner multiple choice because you never know what he's going to do. They might pick the wrong answer for you. So just put one answer which you are so sure of. Okay. So that's page 14. Okay. So we'll delete our answers so that we can move down the page. Okay. All right, so we have done B, part one and part two. Okay, we're going to go down to ammonia. Okay, uh, ammonia is a very simple covalent molecule with covalent bonds. Describe what is a covalent bond. The keywords, what the examiner is expecting here. What is a covalent bond? You need to mention that there's a pair. Okay, there's a pair of electrons. That's the keyword. First keyword, pair of electrons. All right. And then they also want you to mention the fact that this pair of electrons is being shared between two atoms. Okay, between two atoms. So for me to form a covalent bond, I should have at least a pair of electrons and then two atoms present, and in between them they're sharing this pair of electrons. So that would be our answer there. And then what you see down here is dot and cross diagram, which we want to do for molecule of ammonia. Okay, right. Because it's a dot and cross diagram, we expect to see the dots and we expect to see the crosses. Now, if you decide to put the crosses for hydrogen, then it must be consistent. Okay, right. So we're going to put the dots for hydrogen. So I'll put the dots for hydrogen. Okay, one dot for this hydrogen, another dot for this hydrogen. Okay, and another dot for that hydrogen. All right. All right, I'm done with hydrogen. I have three hydrogens, so I've put three dots. I move on to nitrogen, so I'm going to put that's X for nitrogen. Okay, that's X for the other nitrogen, and then that's X for the other nitrogen. Now, if you look at the electronic configuration for nitrogen, I suppose you still remember that nitrogen is atomic number 7. So its electronic configuration is 2.5. Okay, right. So there are 5 electrons from nitrogen, but we have only put 1, 2, 3. So we have to put 2 more for nitrogen. So in essence, nitrogen has 2 unbonded electrons. And then when you have done this, you have done justice to this question because it says dot and cross diagram. Okay, you need to indicate. Okay, dots and cross. Okay. That's the key part of the question. It shows dot and cross diagram. And in this case, I was using crosses for nitrogen, okay? And I was using these dots. I was using this for valence electrons for hydrogen. That's how you would answer that question. Okay, I hope it's clear. I'll move on to the next page. And in order for me to do that, I'm going to delete all drawings so that I can move to the next page. I hope that was the last question for this exam. Okay, aqueous ammonia is alkaline. Choose from the list the pH value that is alkaline. Draw a circle around your chosen answer. Okay, right. We know that ammonia is not an acid. Okay, it's an alkaline. Okay, so it's weakly alkaline. So obviously pH 1 and pH 5, I will not consider them because these are on the acidic side of the pH scale. pH 7 is the neutral point, but now ammonia is a weak alkaline. So obviously our answer is going to be pH 10. That's where my answer is. Okay. And then aqueous ammonia releases ammonia gas. Ammonia gas turns damp red litmus paper blue. Okay, that's the standard test for ammonia. It turns damp red litmus paper blue. So we have this experiment where we have cotton wool that has been soaked in aqueous ammonia, and then on the other side of the tube we have damp red litmus paper. Okay, so obviously the gas that is released is going to move in that way, and eventually it will get to the surface of damp red litmus paper, and then the damp red litmus paper will turn blue. All right, so we want to look at what sort of question was being asked here. Okay, if we go down a bit, they're saying after a short time, the litmus paper turns blue. Explain these results in terms of the kinetic theory of matter. Okay, right. We're just going to outline what are the importance or what are the key words in this answer. You have to remember the fact that what is happening here is the process of diffusion. Diffusion is movement of molecules from an area of high concentration to an area of low concentration. So we are going to explain that, okay? Using the kinetic theory, okay, the molecules of ammonia are going to evaporate. So this is the first keyword, okay? We have to talk about evaporation. They're going to evaporate, okay? So there should be evaporation of ammonia. And then after they evaporate, they're now gaseous, okay? And then what we're going to write down is there's going to be diffusion, okay? They are going to diffuse from a region of high concentration to a region of low concentration. And then our third marking point here, we are going to talk about the molecules. They're going to move in constant random motion, okay? They are gas molecules, so they'll be moving in constant random motion in all direction. Constant random motion in all directions because they are gas. We know that gas molecules have a lot of kinetic energy. So constant random motion in all directions. And then our next keyword here, what the examiner is expecting us to do is to write that the ammonia ammonia gas particles, ammonia gas particles reach surface of litmus paper. They reach the surface of litmus paper. Okay, so we have actually outlined the keywords here, and take note, what we are going to also consider is the fact that we can also have alternative wording, okay? When we say alternative wording, we are saying you can write it in different ways, but this is the marking guide or the key points that you are supposed to write down. So this was part of the paper of May, June 2023, 0620. And you can actually find out that this was the last question. So I always tell students that whenever you're given the paper, okay, just flip through and check all the questions because this question was right at the end. And sometimes you can miss it because you're stuck with some harder questions which would have appeared earlier on in the paper. So this was the end of the paper, and you should also ensure that there is always a periodic table that you're supposed to be using at the end of the paper. So you see there's a periodic table here, and you should always make sure that you refer to this periodic table. This periodic table is meant for you to use, okay? It has groups, it has periods, and that can actually help you to answer questions easily. So that was the short revision session that I thought I could just share with you. Thank you. Bye.